Hello, everyone. This session is recorded in the context of the Festive Tech Calendar 2024. I wish you a holiday season full of learnings and joy. In this session, we will talk about how to build a data API using Data API Builder and Azure Container Apps. I am Massimo Grippa. I work as lead architect for a consultancy company in Belgium called Codit. Here you can find my social contacts and feel free to reach out to connect and discuss about technology and Azure cloud solutions. Now, today we will talk about a company called Datasprint, and we will go through their story. Datasprint is a company that is facing a bottleneck in partnering up with companies because of their old exchange methods that have been put in place in the previous year. So every time they want to expose assets to the outside world to connect or give data to these partners, every time it's time consuming, it's partner specific, so really tightly coupled to that specific consumer, and the onboarding of different partners goes in a very different ways, always ad hoc, and that result in consuming time or wasting resources, and something that overall complex, something that in general should be a no-brainer. Now, with this in mind, Datasprint wants to approach to this project, to this problem in a different way. So they want to surface those data sets to the outside world, to their customer in a secure and performant way, and they want the overall solution to be scalable. Here on the right, we can see the starting point and also the requirement of Datasprint. So this data portion are already available for external use, so the data has been cleaned up and are ready to be consumed. Those views, this data portion or projections, are read-only, available to the outside world, and Datasprint would like their customer to access to this data portion using an interoperable format, something that can be consumed by a large ecosystem of clients. So the access to these endpoints, to this data, must be secured, and they want to make sure that there is no additional development cost every time that a new portion of data has to be exposed to the partner A, partner B, or a new partner. Overall, when it's about development, knowledge, development experience, they want to make sure that internally for their developers, they want to avoid a steep learning curve. They want to avoid complexity for their developers. With this in mind, the approach that has been chosen for Datasprint is to look at Azure PaaS services. Why this? Because they allow Datasprint to innovate faster. So by using these components available in the Azure platform, they can leverage the features of those out-of-the-box components and reduce development time. So they don't have to reinvent the wheel or building up a feature that is already present in a component. They want to optimize the cost by making sure that we are using those resources efficiently in the cloud. We just only pay per use, and we don't have to incur in a huge cost. And last but not least, we want to leverage PaaS to give our developers the possibility to operate with confidence. What does mean? It means to add security, add resiliencies, and add performances with no cost or having a low entry point for them. Now, let's go through these three steps, like the innovate faster, optimize costs, and operate with confidence, and see how we can use Azure technology to make sure that we can fulfill the use case of Datasprint. Now, innovate faster. So remember, we want to expose easily our data sets, our projections, our review. So one way of doing this is to use Azure Data API Builder. So Azure Data API Builder is an open source tool launched by Microsoft last year, so in 2023, and that has been made generally available this year in May 2024. So the API Builder gives you the possibility to take a table, a stored procedure, a collection in Cosmos if you want, and turn those data objects very quickly in a REST or a GraphQL endpoint. These endpoints, they support pagination, they support filtering, they support selections, and other features like a relationship in GraphQL just by default, so you don't have to develop any new things to support this data filtering, for example. It works with SQL, it works with MySQL, Cosmos, Postgres, and in the future, potentially other database will be added. It is built with security in mind, so by default, it will expose as less as possible. By default, is integrated with OpenID Connect, OAuth 2.0. By default, can also be configured to use authorization by leveraging the DAB policies that are linked to the claims that you might have into your job token. We'll see this in a second. And it also allows an easy deployment because it's packaged as a NuGet package, or you can have a containerized version of it, and it will come in a second. Now, if you look at DAB, how does it work? Super simple. We need to start on the left, or we have a GraphQL schema that define our objects on GraphQL, or we can start from an existing SQL database. If you add on these 2 points a configuration file that describes what we want to expose, so not the full database, not every view, but only what is defined in that configuration file. These 2 starting points together will be passed to the runtime of the API Builder, and the API Builder will create all the in-memory abstraction to make sure that we can expose them to the outside world, or REST endpoints, or GraphQL endpoints. And then we can use our client to consume those endpoints in a secure and efficient way. So bottom line, an existing, if you want to start from a SQL point of view, a SQL database plus a configuration file. Now, how can we start with the API Builder? Very easily. I can use my .NET tool, install and passing Microsoft Data API Builder on my command line. Then, in this case, I will download automatically on my laptop the runtime of DAB, the API Builder. Then, if I use the tool, the DAB CLI, DAB init, I pass a database connection in this case because I'm using SQL in this example. So I can create with this DAB init the configuration file that contains the link to my database. And then by using add command, I can add to that configuration file an entity. In this case, I'm saying I want to expose the special deals view or table, and which kind of permission I want to use, in this case, anonymous. These 3 commands will initialize the tool, initialize the file, and add an entity to the file. If I run dabstart, I will be able to host locally or in the cloud then my API, so that will give access to my database. Now, before continuing and going on in the demo, on the other point, one thing is very important to notice is that exposing your database model is a well-known anti-pattern. So we have to be completely aware for different ways, so different motivation. We don't want to have a tight coupling between the APIs and the database model. We don't want to expose all the fields. We don't want to give use the same data type. Maybe we want to change data types. Maybe we want to change the name of the field. Maybe we want to add some fields. We want to remove fields. Maybe if we expose directly database, some features of those database might be used not in the right way. So then having problem with performances. Okay, so these are all well-known things. Here in this case, what we said at the beginning, the data that we are exposing is already ready to be consumed. So it means that it's already been through different stages, already, let's say, filtered, already clean up, and it is at the end of the day ready to be used in a read-only way, so and not giving the access to the full databases or features that we don't want. So every time that we are using a tool, so be mindful on the technology that you're going to use, how to use it, and not how to misuse. Okay, so let's now move on a bit more about DAB, so you can work with Entra ID, so you can use it in a non-authenticated way, but also secured by Azure AD. We can define roles in action based on specific role, which is a claim in the job token. I can decide, okay, that claim is read, that kind of claim as create or delete actions. And also I can use DAB policy, as you can see at the bottom of this, in combination with roles to make sure that I can add additional filter on the database. So I might say, okay, if I'm authenticated and I'm part of the management role, then I can filter already, additionally, my request, in this case, by a specific buying group name, or I can also use the claim that I receive, or for example, the user ID that I receive with my job token to filter the data that belongs to myself. Now is a time for a first demo to get a first sight about data API builder. Let's go through it. Okay, so first of all, we have a database where we are starting from. Here we have this DAB CLI testDB, and I have some tables, or if you want, I was saying some views that are ready to be consumed. So these DAB customers, DAB suppliers, vehicle temperatures, etc., etc. So we will use this classic SQL view to expose our data to our customer. Now, let me go to my Visual Studio, and let's see the experience of DAB on localhost. Let's go to this table. So first I run this command. Let's do like this. I run this command here, and I create my DAB file. Let me close this. I don't need it. Okay. And I am doing, as I was saying before, I'm running this, installing the data API builder. It will, in this case, I'm running an update. I already have the latest version. If I run this DAB, let me make it bigger for you. If I run this DAB in database, and you see here that a new file is created with my connection string and just a set of static or empty sections. Here we have empty object. Entities are the entities that I'm going to expose. Now, going back to my command, I can add special deals. In this case, a section in the file has been added. So I'm gonna expose the special deals. It will be a REST endpoint, and I'm gonna use the anonymous schema. And then at the end of the day, as a last step, I just run my DAB start command. You will see here that my API will be hosted on localhost port 5000. Now we are ready to go. So let's see how can I explore what has been hosted at this localhost. So first of all, if I just call the base address, the port 5000, I will be able to get a sort of health endpoint. I can see what is the version of my DAB runtime, and I can use this if I want in the context of probing my my API. Then we expose the entity special deals. Here we saw before, and that means special deals. That means I will be able to access to all the special deals here in my database, okay? And then I will be able to filter on a specific specific deal ID. I will be able to filter by getting a discount percentage greater than 5%. that's not what I want to click. Okay, and here I get my data back. So this is a filter, let's call it again, okay, with discount percentage greater than 5%. And then I can also select which filter I want. So I want to see on which field I want to see, only special ID and the description in that case, and so on. So I can create, I can delete, there are different kind of things. So these are very quick look to explore which kind of features DAB allow us to, gives to us. So for every operation, it's possible to get all the verbs to do a sort of crude API. So create, read, update, and delete. So here, if you want, I can delete one field, or we can see also the create. That's a new one. The specialty 29 has been created. I can then delete if I want the 29. Okay, that's done. It returns for no content and so on. Okay, here I'm running in my console application, but of course I can also get a container and run it as a container. Okay, this is a first very quick way on how to first sight on data API builder, but we also said that the data sprint, they want to add security on top of it. They want to make sure that the people needs to authenticate and be unauthorized to get access to a specific object. In order to do this, let me first go back and grab a token. So in this folder, I have my get token script to get a token from the Active Directory. So my password. Okay, so this is the token, and everything has been, let's say, configured before. I go to this jot.io, and I can explore my token, and I can see that I have here two roles, operational and management. So my user Massimo has been configured with these application roles, management and operational. So I can leverage these roles to do additional filtering in my API. Let's see how. So I go this, we can close it. So I just copy my token again, and I am able to do that. And I copy here, then later I will use it. But now let me go back on the folder where we are doing the localhost test, and I just gonna delete this config that we created a few seconds ago to create a new one with this security in mind. So this will delete my file here on the left, and now I create a new file by specifying which authentication provider I'm gonna use. So what is my Active Directory issuer, and for which APIs, so which audience Active Directory will generate a token. Active Directory has already been configured, and then here I will add different entities to my file with different, let's say, permission. Some objects will be anonymous, will allow an anonymous access, and other entities will have more complex access. Complex in the sense with more security. Now, this is done. And let's see the result. I have here at the bottom all of my entities with all the permissions one by one. So this is the customers. The customer has these permissions. Okay, so Anonymous can read except all the can read all the customers except the alternate contact, and by default they can get only some category name equal to supermarket. So if I'm not passing a token, I can read everything about customers except the alternate contact, and I can read everything that belongs to the category name supermarket, etc., etc. So we can go and see. So if I have a role executive, I can read everything. If I have management, I can read everything, but that not equal to tailspin toys. If I'm operational, I can read, I can delete, I can do whatever action I want. So this is basically what has been done in the context of the customer's entity. Now let's run this. So dub start, and I can now explore my secured dub things, dub API, so in an anonymous way, and I will get everything that belongs to the category supermarket, as I said. If I call the customer but with a bearer token, so and say, okay, we specify which role I want to use. Well, I have to specify the role because, as I showed you before, in my JOT token, there are two roles, two claims with different roles. And then in this case, I will get a read, but with some filtering done with the dub policy. So if I call the customer but with management role, I also have a different view on the data. If I want to delete, if I want to delete something where it is deleted here, I will be blocked because the management role cannot delete the data, only the operational role. So that's the way I can use dub in combination with a token to define which kind of role I have and filter, and also the actions that are allowed. Okay, let's stop my here the console, and let's move on with our presentation. Now that we saw how to quickly expose our data as a endpoint, let's see how we can achieve more with less by leveraging PaaS. So now, if we want to host our APIs, not on that we saw on localhost, and we want to host it in Azure, so our customer will be able to easily reach the endpoint and fetch the data. And the easy way to run the dub in the Azure Container Apps is the easiest way to host a container. Azure Container App focus on the application and not on the infrastructure. So all the management of the infrastructure behind, that is Kubernetes based, is managed by Microsoft. That abstraction will allow the developers of DataSpring to not learn all the complexity of Kubernetes. And it also will allow to scale to zero. As you can see in the image, if I call the customer API and it is there, the traffic will be served. If there are no calls, I can scale to zero. So when this endpoint is not used, DataSpring is not paying the cost for that container running. Now, yes, so one thing is scale to zero, another thing is also scale based on the traffic that is in. So it might be that during some particular days of the month, there are more calls towards a specific endpoint. In that case, the container apps can provision additional instance based on some dynamic events that are observed on some points. In this case, as you can see at the point 2, we can scale based on concurrent requests. So in this case, on HTTP requests, but Azure Container Apps, by leveraging KEDA, you can scale by using the number of messages in queues and using other events. Okay, so what we're going to do here, we are going to make it simple to automate and make it a click-based deployment of Azure Container Apps, where you can say, okay, I need to create an operation or an object. I need to expose the specific object, what is the minimum instance and what is the maximum instance. So I will be able to control by configuration how much power I want to make, I want to provision, let's say, for that specific customer. Now, another interesting thing about DAB is that DAB integrates with, so it has a memory cache out of the box. Memory is extremely important to increase the performance and the availability of a service. So the cache in DAB is powered by a community library called Fusion Cache. And as I said, improve performance, improve availability. It gives, at the end of the day, a better user experience, because if something goes wrong in the backend, this caching it gives to your service a stable response, a stable, let's say, behavior over time. And also, in case of errors, you can protect your database and all the resources that are behind the API. That's very interesting features. Let's go into a demo and see how we can get our API to the cloud. To do that, let's go to the folder number 1. Okay, here where we do have our simple publishing. And I have this script where I deploy some infrastructure that will be used that is needed to like the Container Apps environment, the Container Apps application, and then for every time that I want, by leveraging convention, every time that I want to expose a view, I can create like this, create a HTA app and specify which view on my database I want to expose. So if I need in the future to expose more views without any development, I just create here like suppliers, and then I say, okay, I want minimum one replica and maximum 5. This kind of experience I'm looking for my developers. Okay, so now let's run the deployment script. It will create this super simple application on Azure Container Apps it will create some log analytics and other shared infrastructure. Let's give you some idea of the script. So on the application environment, I create my Container Apps. I will add a storage and all of the other things that are necessary for running the tab. Let me go back 1 second on the slides. So here, in order to run the tab on Azure Container Apps, I need to link storage account to the Azure Container Apps environment, deploy my image into Azure Container Apps, and then upload the DAB configuration file into this storage account, and then the Azure Container Apps will pull this file from the mounted storage. Now, getting back to our demo, is going through the different things. So different uploading, as you see, the configuration file, and then running all the single details. So we set the infrastructure, the application environment, we were saying, and then create an Azure Container Apps application that is running this bicep file. At the end of the day, uses this image of data API builder. The other interesting part are the mounting a volume, and to mount a volume, you need, of course, to specify which volume are you going to use. So long story short, this, if you go back to our resource group, at the end of the day, this creates this super simple customer Azure Container Apps. If I'm going into the console, I will be able to see what's happening. The console, it allows me to connect directly on my container and see. Also here, I should be able to find the folder where I'm uploading the DApp configuration file. If I go on the log stream, I can understand what is going on. And because here, when we deploy our configuration, DApp consumer, we set up the mode development. When I call my application, I will be able to see the trace of the SQL command that is sent by DAB to the database. Now, let's look a little bit a quick test on this. So now, instead of calling on localhost, I can call my super simple Azure Container Apps. I can filter by category name. I can just select only few fields. And if I go on Azure, I can see here, let's just clear 1 second and run it again. I will be able to see, let me refresh the console. I will be able to see all the commands here because it's in the debug mode. Yeah, so for the moment, that's very simple. Nothing more complex than this. So Azure Container Apps will host, if I show here my replicas, it will host two replicas, and this replica contains the DAB, the Azure Data API Builder image. Let's go back to our slide deck now. So in this case, we saw very simple infrastructure, Azure Container Apps infrastructure. I can scale to 0, I can scale to 1, 2, 3, 20, depending on how much I need, and just I pay for the usage of my API. Now let's see how we want to operate. We can operate in a more secure and reliable way. Okay, so if I create multiple endpoints, so if I create, as I was saying here, one endpoint for, if I create multiple endpoints, one for customers, one for suppliers, and so on, I will end up in a situation where I do have for every view that I expose a different endpoint. As you can see here, my customer endpoint, my supplier's endpoint, my special deal, etc., etc. So that it means that I will have a bigger attack surface. So more APIs, bigger the attack surface. So more complex to consume for my API consumers, for my customers, to the customer of the data sprint. Because if I'm customer A and I have to use 3 operations, I have to use 3 different points. And also from our side, it's complex to maintain because we have to maintain users and versioning for every single endpoint because they are at the end separated and managed in a different way. Now, how we can have something that is easier and better and more secure? So first of all, we can turn our Azure Container Apps from external mode into internal mode. So all of these 3 endpoints will not be accessible anymore to the outside world, as you can see here. So in this way, I limit the access to this operation only from within a specific network. Then, if I put something on top of it, so a sort of ingress, a route mechanism on top of this, I will allow the ingress from the outside world and the access towards this different operation only with a single point. So there will be a single endpoint exposed And this way I can manage in a single way all the authentication and all the authorization of my users. In this single point, I can monitor the traffic in a very centralized way. By also introducing this gateway, I will be able to decouple the version that I'm exposing to the outside world with the version that I have internally. So I can decouple the life cycle of this facade object from the life cycle of the object that I have here at the right of this picture. So in this way, there are multiple products that allow this kind of API management feature, this gateway feature. In this case, we see how we can use Azure API management and host Azure API management into Azure Container Apps. So these container apps will be the only one with public access and will be a mediator between the external world and the internal world. So, and because I'm using API management, I have full control on the API. I can, if I have my 3 or 4 operations, and for every operation are exposing 3, 4, 5 verbs like the create, the put, etc., etc. I can decide which kind of HTTP method I want to expose and which one not. I can also decide which complete part of or segment of the API I want to expose and which one not. I can decide whether to implement or how to implement a throttling policy. Here on the right, you have an example of the policy that throttle errors, but also non-errors, so both of them. So and normally, one of the things that we always advise is to always throttle, but to throttle even harder when there are errors. You can implement a resiliency policy depending on what are your needs, on API management point of view, but also on Azure Container Apps by leveraging the Dapper resiliency policy that is built in on Azure Container Apps. And the other things, by filtering, by being API management in the middle, you can filter what is in, but also what is going out. So the way back to the customer, to the caller, the API caller, the API consumer. So in this way, we can mask internal implementation details. We can apply whatever policy, security policy we want to impose, we want to apply on our API management. Okay, so let's go a little bit into the next demo. Let's go to this folder, A03 API ingress, where we have a different deploy scripts. The first part is very similar to what we saw before, where we have the shared infrastructure configured, and then we have our Azure Container Apps environment creation. The things at this point at line 10 starts to go different, in the sense that we are going to create an API management configuration for the self-hosted agent. We are going to create an Azure Container Apps dedicated to hosting this API management self-hosted, and we are linking the instance of API management to the self-hosted gateway. This is done, let's go quickly through this, by calling this create facade. Let's go through it. The create facade create an object of API management gateway. In the ARM, it creates an API which will contain the virtual facade, the virtual API. Here we have a gateways object. The API associated to the gateway. Some policy, some named value, loggers, and diagnostic. These are classic API management objects. So this is the part of the facade for API management. Then we create, we deploy the API management, so the self-hosted gateway in the container apps. This aka APIM ingress. That's what I was showing. So that I'm going to show. So here is a classic container apps, as we saw before. but now in this container apps, we are hosting the API management gateway instance. This is about. And as a final step, here we then create some keys that can be used to call this API, because we will authenticate for this example with API management using a subscription key. So this is the self-hosted part, and then as before, we will create 4 operations. So 1 Azure Container Apps per DAB view. So every Container Apps will contain a specific instance of DAB that will expose a specific view. In this case, the customer view, supplier view, temperatures, and so on. So if you run this deploy script, the end result will be like the following. So I'm in my DAB ECA resource group, and here I do have my ingress and then the operations, so customers, special deals, suppliers, and vehicle temperatures. There is a main difference between the ingress and all of these operations, these 4 operations. Let's check it. So these operations are internal. So here, if I just check the application URL, you will see there is a part of the FQDN that contains internal. If I click on this, I will not be able to get this to this data. This is internal. You can see this in the ingress section, where the ingress is enabled, but the data, the flow is the data flow is only the access to this endpoint is only limited to the container apps environment. So if you have an container apps environment with some application in it, only this application will be able to access to this endpoint, in this case that is exposed here. So and in our case, we are having 4 operations internally, okay, and 1 that is externally exposed, and this traffic will be enabled. So the ingress otherwise configured in a different way. So if we go in our ingress, here we will see it can accept traffic from anywhere, and this container will have a different address. So there is the ingress suffix. If I call this, I will be able to access publicly. In this case, there is no API in the URL, so I have a 404, so I'm not able to find it, but we will be able to reach it in a few seconds. So this is the setup from Azure point of view. So if I go in my application and I go into, for example, log streams, so here I will be able to see the log streams coming from the API management gateway objects. And if I go on the log streams of this container, these are the log stream of the DAB file. So here I see my SQL debugging commands. Now, if I want to test it, I have here to better understand. This is my address. So this is my API key that is used on API management hosted in Azure Container Apps. I can call it my customers. So, and I can, as expected, I reach API management, and because I have an API key, I'm able to use it. So to secure it and then forward the address. So if I call it without the API key, as expected, I have a 401. Now let's get back to the API key here. I can then, of course, find, I can call other operation. I can call the get, this filtering. If I try to call the delete, I will have a 404. Why this? Because we said we want to expose only some operations and not all the posts. So we only want to expose the read-only operation. So what did we do? In API management here, when I go on my API and on my DAB on ACA API, you see we did not expose all the operation exposed by the DAB, but only the get. So we can select only what we want to expose. Here we have also the policy that implemented the throttling, as we said before. Now, what else? So we can have, we saw for customers, we can also have, we can try our suppliers. And if I remember properly, the special deals is configured to scale to 0. So let me double check here on the revision. Yes, you see that we don't have, we have a 0 replica at the moment. So if for suppliers, it went fast, the call, because it was already available. If I click on special deals, you see it's taking sometimes, this is still our suppliers. So the container apps has to create an instance, so moving from 0 to 1, so that takes sometimes to answer, and it could be not a very good experience for our customer to wait. I don't know now how long it was 15 seconds or so. Actually, it's here 20, we wait 24 seconds to get this answer, quite a lot. This is not the customer experience that we want to provide. So how can we react to this? We can, I configure it on vehicle temperatures. On vehicle temperatures, here if you search for resiliency, we can define some resiliency policies. So we can have something that sits in front of our DAB containers, and in this case it's Dapper, and this Dapper intercept the calls and can manage the timeouts, or can manage some errors that I might have on DAB. And let's say in case of errors, I can close the circuit, and I could respond fast to my consumer. Therefore, the consumer will not stay 24 seconds waiting. He can have fast errors and implement a retry logic. The example here, just like to visualize, let's go back a little bit. So this Dapper here is in front of the vehicle temperatures. So if there are some errors on coming from the Azure Container Apps, you will loop shortcut this call until this guy is healthy again, and will give then access to the feature or the operation that we are looking for. Now let's to look this in action. We can see, we can evaluate here the experience. So the difference between the 24 seconds that we saw for the special deals. Let's see what will happen in the case of vehicle temperatures. So that I'm gonna call 150 times this operation. So it first returns a couple of 504. Okay, then Dapper understand that something is the service is not available, and it creates a circuit breaker. It closes the circuit. It returns for a certain amount of time 503, okay, until there is the service is up and running, and then it returns the 200. So in this way, and then here it throttles again at 429, because that's the API management policy and not the Dapper policy. So in this way, we can gracefully handle, by using this resiliency feature, what happened I mean, the possible errors or inefficiencies that we might have in the backend. So let's now come a little back to our slide. So what did we see? we saw that we start from taking a view, a SQL view, and expose it as a REST endpoint. Then we went from one view to one view per customer by just configuration. But by using conventions and configuration. But then we had too many endpoints, so we decided, and we didn't want to expose all of this operation. We went in a more secure setup where we have API management on Azure Container Apps in front of all of our internal APIs. And this facade API is a compound API, is a composition of 4 APIs, but is also implementing filtering, it's also implementing throttling policy, is implementing resiliency policy via Dapper, and also security, in this case, using API keys. Or we could also move from API keys, of course, to JWT token and use the integration with Azure Active Directory. So at the end of the day, we have a single endpoint and not 4 endpoints, filter operation, and better governance and security. That's bring us to the takeaways of this session. We achieved a quick time to market by leveraging the data API builder. So we were able to go faster from some views to an HTTP endpoint. We can add new views just by a little configuration. We are using a REST endpoint, so REST, or if you want, JSON over HTTP, that guarantee a better interoperability and integration. So there are tons of tools that are managing, for example, the OpenAPI specification, tons of tools and everything that is able to handle JSON. We were able then to optimize the cost by using PaaS services that can abstract the infrastructure, so we don't need to learn about Kubernetes, for example. We can scale to 0, so optimize the cost. Also, DAB, by being only a configuration-only tool, reduced to minimum the cost of developing, a cost of exposing a new data set. That's what, by making some configuration-only task. And then also by using the caching feature of DAB, that we are able to also then reduce the workload, so the access to a SQL server that we have on the background. This PaaS approach, empower developers by giving them a very easy integration with Active Directory, by giving them a tool to keep under control the security. We saw filtering, adding policy, adding resiliency with ACA. So at the end of the day, we were able with this approach, with the PaaS approach in Azure, to let's say give an answer to the data sprint requirements that we saw at the end, at the beginning of this session. Okay, that's everything for today. So I hope this session was interesting for you. Thank you for joining the Festive Tech Calendar 2024, and I wish you a lovely festive days.